I am going over Unit 5, Day 2 notes. And since it's a short portion in each, I might be able to do all of them in one video, and then then we do the classwork in different parts. So what we're dealing with is similar triangles. And how do we know if two triangles are similar? One thing we know about anything in any kind of shape, it doesn't have to be triangles, but if two figures or two polygons are similar, then two things has to happen. One, their side has to be proportional. So sides are always going to be proportional. So write this down. Sides are going to be proportional. And then the angles are going to be congruent. So that's the big difference between the two. Sides are going to be proportional. Angles are going to be congruent. So make sure you remember that. Similarity symbol we are using is just this wiggly line. And I know you have seen it in Unit 2 when we talk about it as not. But if we put it between two triangles or two polygons, it means they're similar. This is a similarity statement. So in this case, I have these two triangles here, triangle 1 and triangle 2. And if I wanted to write that triangle 1 is similar to triangle 2, I can just say triangle 1 is similar to triangle 2, right? That's my similarity statement. Or I can just write the whole thing saying triangle ABC. So we put triangle ABC, A, started from the 3 line to B to 2 line. C is similar to triangle H, R, T. Okay, so the A and the H has to be in the same order. The B and the R need to be in the same location. C and T have to be in the same location. That is very important. If you don't make them in the same order, then your statement is going to be different. So what is the scale factor of this triangle? Since they give us a number, I can take any two pairs, right? So if I take, A to C, it has 4, and then 3 to 1 is going to be with H with T. What I mean about 3 to 1, this one has 1, 2, 3 lines here, and this one has 1 line. So I choose the side between the 3 line, right? 1, 2, 3, and between the 1 line. That's why I said 4 to 8. So the scale factor is going to be 4 to 8. 4 over 8. I just chose that, and then simplify it. It will give you 1/2. Okay. If you chose 1.5, let's say 1.5. this side, then you have to choose with the 3, right? If you chose the 2.5, and you have to choose the 5 to write the scale factor. But all of them would give you the scale factor. So what is the scale factor of the above triangle? Is 1/2. So if you take all of them and simplify it, you just get 1/2. So now let's do an example. So given triangle CDE is similar to triangle HJK. So the first thing they're asking you is to list the pair of congruent angles, right? So I don't even if I don't, see any marking for the triangle, I look at C is in the same location as H. That means C and H are going to be congruent. So I can write down angle C is congruent to angle H. D is the same location as K. So D is congruent to K. So I mark it. So I can say angle D is congruent to angle K. Right? And then the last one is E is congruent to J, right? E and J. So J is here. That would be the 3 line. And E would be the 3 line. So I can say angle E is congruent to angle J. Okay, that is your congruent angles. When they ask you proportional statement, so since the sides are proportional, right, here is what it says, the sides are proportional, I have to write statement of proportionality. Meaning instead of just I have to set ratio between the two triangles. And always, this is something I always do, use the statement, because that makes it way easier than looking at the triangle. So the first two letters are CD, right? Over, what's the first two letter of the next triangle? HK. HK or KH. Let's just do HK. So that you guys is going to be congruent to the second letter, which is DE, congruent to over the next letter is going to be KJ, right? It's congruent to the first and the last letters, which is C with E, whatever length that is, over HJ. This is called statement of proportionality. So you put the lines on top. Okay, that's what we got. Okay, that is proportionality statement. Congruent, you list all the angles that are congruent. Statement of proportionality, that's what you do. So in example 2 says, given FRI is similar to day, write the statement of proportionality. So I want you guys to use these letters and do the same thing I did here, right? And then angle R is going to be congruent to what angle? A. Do I know what A is? If not, find A, because you know triangle always add up to 180 and you can find it. And then I want to find AY. So A to Y, this is what I'm trying to find. So we have to do the ratio. So what I can do is this one is kind of help you set it up. So here, FR, which is FR, is 3, and DA are going to be my ratio. So I can do 3 over 12 equals, then the other side is going to be 5 RI AY, right, with AY. So I can do 5 over X. So what is X? So cross multiply and then find it. Okay, so this is the first part of the note. So I will go over example 6 in class. So this is, if you want to do it, you can do it if you want to, but we'll do this in class. So the next one is, so every time you're given, remember we did with the congruency statement, now with the triangle similarity, we can only use 3. So if we can show that the two triangles have 3 sides that are proportional to each other, if the 3 sides of a triangle are proportional to the corresponding side of another triangle, then the two triangles are going to be similar. Okay, so in this case I looked at 1/2, right? 1/2, 3 over 6, and then 2 over 4. But when you look at them, they're not the same, right? But if you simplify them, 1/2 is 1/2, 3/6 is going to give you 1/2, 2/4 is going to give you 1/2. So this shows me that all of them have the same scale factor. Therefore, JKL is going to be similar to X, Y, Z by side similarities. Okay, so when it's not given to be similar, you can prove that the two triangles are similar by using what is given. So now in this case, they ask you to write the statement of similarity. So I have the statement of the proportional statement is what they want you to do. I have statement of similarity here, so I can just use, okay, the first 2 letters with the first 2 letters of that one, right? So I can do JK over XY is congruent to the next 2 letters, which is KL over YZ, right? You can put the line on top of it, equals to JL over XC. Okay, that what is the scale factor? 1/2. Okay, that's what we have to do. Which triangles are similar? So what I want you to do is, what is the similarity statement? So after you identify which 2 triangles are similar, write down the similarity statement. So this one, just look at it, 1, 2, and 3. and then do the small side. A lot of times, since they didn't give you the statement, the small side 4, the small side is 6, the small side is 6 here, right? So make sure they are proportional, okay? Then the next one is 6. This is the next one is 10. I'm just looking least, medium, and the largest, and this is 9. So that it should be enough. So 4 over 6 is the same as 6 over 10. If that is the case, then 1 and 2 are similar. If not, then you have to do 4 over 6 to decide 6 over 9. Would that give you the same statement? If it does, then that's what you guys have to do. Okay? All right, the next one is side angle side. Okay? Side angle side, as we discussed it with the congruent one, you need 2 side and an included angle. If it is not included, then it would not work. So in this case, you can see that 1 and 3, 2 and 6, including J, right? So if an angle of one triangle is congruent to an angle of a second triangle, so remember the angles have to be congruent, and then the length are adjacent to each other are proportional. They don't necessarily be the same. So you have 1 1/2, 3 and 6, both simplified to be 1/2. Yes, they are proportional. J is congruent to X, they're congruent. So JKL is going to be similar to X, Y, Z by side angle side. Okay? And it's the same thing that we use to prove. So now they give you a couple of examples. In example 1, it says, show that JMK and JSQ, so JMK is this top triangle, right? This top triangle is similar to JS, the big one, which is JSQJ. So they both have J as common, right? That makes the J the angle that they have in common, right? Okay, that makes it the reflexive property, it's congruent. So what I need to do is I need to prove if the sides, if JM over JS has the same scale factor of JK over JQ. Okay, if that is the case, yes, the two triangles are congruent by side angle side. So what is JM? 4. What is JS? 4 plus 12, right? 4 plus 12 equals to what is JK? I can't see. I guess this is the eraser. What is it? 5, right? Sorry about that. So 5 over 5 plus 15 is the whole thing. So which gives you 4 over 16, right, equals to 5 over 20. So when we simplify it, 4 over 16 is what? 1/4, right? 5 over 20 is also 1/4. So the sides are proportional. So I have the sides, I have the angle. So the two triangles are similar by side angle side. So in this case, JMK is similar to JSQ by side angle side. Okay, so that's what we have to do. All right, in this case, and I like the word problem because it really makes, you know, the real life visible. So in this case, the following problem can be solved using similar triangles, and they gave you the two sides. So one thing I want you guys to be careful is when you set up the side, just always make sure the height goes with the height. So this is the height, right? This is the base, and this is the height, and this is the base. So whichever way you do it, just make sure you guys are relating it. So in this case, I can do x over 5.5 equals 24 over 10. That is one way of solving it. or I can do the height with the base of the same triangle. I can do x over 24 equals 5.5 over 10. So whichever one you choose, it should give you. And then the two proportional parts, because it's given that they are proportional. So you find the missing part. So example 3, I guess try to do it, or if not, we'll do it in class. Example 4 also will get done in class. So the last part, that's why I like to do it this way, because I know we'll have time, we have more time. I just wanted to, because this is really important that you understand all of them at the same time, and then we spend most of the time in class doing the problem. So the last one is angle similarities, okay? So the other two, you need to have 3 sides being proportional, or 2 sides, 1 angle. But if you only know about the 2 angles to be congruent, you can conclude that the triangle is similar. So it says if 2 angles of one triangle are congruent to the 2 angles of another triangle, then the 2 triangles are going to be similar. Okay, in this case, J is congruent to X. They're the same measurement. And L is congruent to Z. They're the same measurement. Therefore, JKL is similar to XYZ by AA. Sorry. Angle similarities. I don't need to know anything about that another side, okay? So we will go through it more in class, but I just wanted to do one more problem in this page. And then, when we start doing the classwork, it repeats, it has its own pattern. So the first one is Vx and Zy are parallel. That is a given information, right? All right, and then what would they give you that they are parallel? It's always something, okay? So, and then what is reflexive? So you always have to see what is common in the alphabet. So WW, so you can say angle W is congruent to angle W, right? And then the reason, see, I got my 1 angle, so I can either use V is congruent to Z, right? Or I can do X, this X is congruent to this Y. Whichever way you want it. You only need 1 more angle. So V can be represented this different way. So I can say angle WVX is congruent to angle Z. By what? I hope you guys remember corresponding angles. Because I knew these lines are parallel, right? I knew this is parallel to this line. Okay, and then I can say, oh, the 2 triangles are similar by AA similarities. Okay, so that's what we have to do for this section. Even if, side, angle is the similarity statement we're using, it's the way they ask you the questions are going to be different. That's something you have to differentiate. So in this case, it says find the missing side of the triangle. So these are more of the proportional parts in a triangle. This is more of day 4 or day 5 notes, but this is the only example we have. So what I will do is I'll just do 1 example, and then you'll be done. So you don't have to watch any more videos for this unit, okay? I know it's almost 20 minutes. So in this case, if you know that the 2 sides are parallel with each other, then they cut the proportional part. So I'm looking for this X, right? So what I can do is this portion over this portion, right? So I can do 4 over 8 is going to equal to the other side, which is CE, which is X over 12. That's one way of doing it. Or I can do 4, right, that side, 4 over the whole thing, right, the whole length, which is 4 plus 8, which is 12, right, equals to X over the whole thing on this side, which is X plus 12. Okay, that is one way. Another time, you guys probably can say, what if I do it from 4 to X? You can. 4 over X equals 8 over 12. Those are proportional part too. So when you do this, you'll get to the right answer. So whichever way you do it, you guys can solve it, and all of the solution would be the same. If you use this method, the answer you're going to get will be the same as this method, They're all x will be the same thing. But stay consistent. Don't jump all over. Like you can't say 4 with 12, right? And then try to cross it. It wouldn't work like that, okay? So just make sure you pay attention to it and try to get it done. So I have to be done before 20 minutes is up. So I will see you in class.